Hello there, I'm Mr. Math Guy, and today we're going to take a look at a 10-minute video on the area problem part 2. Previously, on the area problem, we briefly discussed how to calculate or to approximate the area underneath the curve by dividing the curve up into equal subintervals of rectangles and figuring out the sum of the area of the rectangles. And area of a rectangle was A equals base times height. So let's take a look at a couple of problems, some examples, and show you how this is done. So let's say we have this y equals f of x, the part that's in blue, this function, y equals f of x, and I want to find the area underneath of this curve. And so I have the shape kind of outlined there in black. I want to find the area of all of that. How am I going to do this? Well, let's take a look at some values that are going to be important to us. Here, this f of 1, when I plug in 1 for x, I get 1 for y. And the second part, when I plug in 2 for x, at 2 for x, I'm at 2 for y. And up here, right up here at this point, when I'm at 3 for x, I'm at 4 for y. So f of 3 is equal to 4. Now, these values are going to be important. Now, what I want to do is approximate the area A, choosing u as the left endpoint of each subinterval. So what I want to do is divide this up just into two subintervals. So this graph goes from 1 to 3. So what I want to do is divide it up right here into two subintervals. So the first one's going to be from 1 to 2, and the second one's going to be from 2 to 3. Now, let's take a look at what this looks like from the left end. So from the left end, LE, I just put that left end, the area is going to be equal to, I'm going to start right here, the left end, so it's going to be there over to there, and there's going to be my first rectangle. So that is going to be 1 unit high times 1 unit long. Each unit will be the same, so it's going to be 1. So it's going to be my f of 1, which is 1, times the width, which is 1. So 1 times 1 is 1. Plus, my next one that I'm going to choose is up here at f of 2. I'm going to go over, and so this is my rectangle that I have. And so f of 2 is 2 times 1, and 2 times 1 is 2, and so I have an approximation of 3 square units. Now, just by looking at the boxes, you can tell that's going to be very under what I need because I'm missing a lot. So what I want to do now is take a look and approximate the area A, choosing u as the right endpoint of each subinterval. So what I want to do here is I'm going to start up here at the end, the right side of my graph, and I want to go over 1, and so I'm going to go down. Alright, so my right end, my area is going to be equal to, I'm starting at f of 3, which is 4 times 1, and 4 times 1 is 4. Plus, then I'm going to come over here at f of 2 and go over and down. So I have that. And so at f of 2, that's 2 times 1, because the width of 1, base times height. And so 2 times 1 is 2. And so I get an area of 6 square units. Now, that area is a little high, because you can see I'm finding some area outside of the curve. But what I do have, though, is I have from the left end, I got an answer of 3, and that's under. And from the right end, I have an answer of 6, which I know that's over. So at least I know my answer is somewhere between 3 and 6. Now, if we split this up into more subintervals, the more that we do that, the closer we're going to get to our area underneath the curve. Alright, let's take a look at a function f of x is equal to 3x. and is defined on the interval from 0 to 6. Let's first of all graph this function. So this one we should be able to graph because it's just going to be linear. So our y-intercept is 0, and it's going to have a slope of 3, so up 1, 2, 3 over 1. And so if we graph this, it's linear, so the slope is 3, the y-intercept is 0, and it kind of goes off of my screen here. It goes way up there, all the way up to 18, 618. But nonetheless, we can kind of at least see at least part of this graph. Now, if I partition this in 3 subintervals of equal length and choose U as the left endpoint of each subinterval, since it's 6 units long and I want to divide it into 3 equal intervals, that means I'm going from here and there. All right. So my first box that I would have, starting for the left, I don't really have one because I'm starting here. You got to start the graph and go over. So there's not really a box. But from my next one, I would have from here over to, and so I'd have the area underneath this part. And then I would have at 4, I would have up at 12, which you can see on my screen, and it would be this box. Now, what I would do then is figure out the area. So this one is 2 units long, and this one is 2 units long. They're all 2s. The height of the first one is 0, because I started here, so I got 0 there. All right, so I have 0 plus the height of this one is 1, 2, 3, 4, 5, 6. So it's up 6. Or f of 2, if you plugged in 2, 3 times 2 is 6. So 6 times 2 is 12. Plus this next one at f of 4, 3 times 4 is 12. So it's 12 units high times 2 is 24. So I get an approximate answer of 36 square units. Now this would be choosing it from the left endpoint into 3 subintervals. Now, let's say we do the same thing from the right. So you can't see it on the screen, but I go all the way to the right, and I come, and it would come down this direction, and I would have that big box. So if we had f of 6, we'll plug in 6. 3 times 6 is 18. So it would be 18 times 2, which is 36, plus come over to the next part at 4, so it would be from here over to 2 and come down. And so that one is going to be at 4, be 12 times 2, which is 24, plus, and then from right here at 2, which is at 6, come over and come down, and that one would be 6 times 2 is 12. And this one would be approximately 60 plus 12 is 72. So from the left side with 3 partitions, 3 subintervals, I got 36, which is under. From the right side, I got 72, which is over. Now let's go from the left side, dividing into 6 subintervals. So the first one, not really going to have anything from the left side. Then here, there's one. And then here's my next one, over. And then here is my next one, over. And then here is my next one, and over. And the last one you can't really see because it goes up higher than my graph, but it looks something like that. So the first box had a height of 0, so it's 0. The next one, f of 1, just plug in f of 1 there. So you get 3 times 1, because my width is only 1 this time, so I get 3. Plus, the next one, f of 2, would be 6 times 1. Then f of 3 would be 9 times 1. Then f of 4 would be 12 times 1. Then f of 5 would be 15 times 1. And my first one, you want to write it down, maybe is 0. So there's 6 boxes. Now, when you add those numbers together, you get 45. So this is dividing it from the left side into 6 subintervals. Now notice, it's a little bit more than 36 and less than 72, so I'm getting closer and closer. Keep doing this, and you're going to come up with your a better approximation. Thank you for watching. God bless. Actually, I don't want to cut you off right there. I'm kind of leaving you hanging. So I'm going to continue. I'm going to go from the right side now. I don't want to leave you hanging. So from the right side, I'm going to have f of 6 is going to be 18 times 1, which is 18. And then f of 5 times 1 would be 15 times 1. And then f of 4, 12 times 1. F of 3, 9 times 1. F of 2, 6 times 1. And 1, 2, 3, 4, 5. And then f of 1 would be 3 times 1. So I'm having all these boxes, all right, going from the right sides. Oops, from right here. And when I add all those together, I get 63. That's a little bit, now it's still a little overage, but notice I'm getting closer and closer. Now, if I wanted to find the actual area of this one, I can, because this is simply just a triangle, and triangles are 1/2 the base times the height. So I know my answer is going to be between 45 and 63. It's going to get closer and closer. So if I'm trying to find the actual area, the area is going to be 1/2 the base. The base of this is 6 units long, and the height of this, it gets up to 18. So 1/2 of 6 is 3, and 3 times 18 is 54. This is the real area of this. Notice it's between these two values. And if I were to divide this thing up into more subintervals, I would get closer and closer and closer to this 54 answer. Thank you for watching. Instead of the 10-minute video, it was 12. Sorry about that. Thank you for watching. God bless.